Okay, I was just saying that for throughput accounting ratio or throughput accounting techniques, you need to know how to compute throughput accounting ratio. And before that, you need to know how we compute return per factory hour, or what you call throughput per factory hour. They're the same. It has two formulas. There's when you use throughput per unit divided by factory hour per unit, or use totals. Total throughput divided by total factory hour. How do we compute throughput? Throughput is given by the selling price minus the material cost per unit. Okay, that is for per unit. Alternatively, you can say total sales, okay, minus total direct material costs. You have the figures in totals, okay. So that is how we get it. Throughput is given by selling price minus the material cost. Then how do I get now throughput per factory hour? We're saying that after getting your throughput, determine the bottleneck. And the bottleneck was given in the question as hours. So they told us that the bottleneck per hour for B, product B, is 0.7. Okay. And those per unit. Okay, 0.7 per unit. If you want to make it total, you were given the number of units. Assuming there were 1,000, we're saying to be the per unit times the number of units. So 0.7 times this. Okay, that is if you want to use totals. Otherwise, for singles, just go as they are. Okay. So, so the bottleneck or the limiting factor, you must identify it. It's one of those things that you must identify. And thank God this one was given clearly. But I already explained how you get it in case it's not given. Okay. Then we determine now our return per factory hour, or what you call throughput per factory hour. It's given by the throughput itself divided by the limiting factor. Okay. And that's how we ended up having 64.57. Okay. So this is not enough. If you have this, it's not enough. Okay. You must get what? You must get now factory or the total cost per factory hour. Okay. You need to get it for you to get throughput accounting ratio. Okay. So you come back here. Now, when getting it, you're saying it's given as either total cost, yeah. It's either given as total cost divided by total factory hour, which is what I used because I was given total cost. So it is this divided by that. You will get 12,700. Okay. So when you have these two items, then you have throughput accounting ratio because it's given by one divided by the other. Just as is the formula. Okay, so this is when you use per unit. When you use totals, you still get the same answers. So I hope Shakira have answered to your question. But now we get the bottleneck. The bottleneck, I said, if they don't tell you clearly that the bottleneck is machine hours or direct labor hours, here, you're supposed to check which one gives the largest output and which one gives you the smallest. The one that gives you the smallest output is the limiting factor because it doesn't allow you to exhaust your maximum. Okay, that's how you get up. That's how you go about it. Unfortunately, I don't want to repeat it. Okay. Okay, but that is it. That if you're given two limiting factors or two factors, say labor and machine hours, the one that gives you the smallest production is the limiting factor because it's not allowing you to maximize the other input or factor. All right, so let's go to now. How did you get the cost factory hour? It's given by total cost, which is in the question. The total cost, it was 140 million, divided by total factory hours, or the limiting factor, the maximum capacity, which was 11,000 hours. So therefore, it's total divided by factory hours. Shakira, I hope I've answered you. So let's look at now, in case you have multiple products. Multiple products, how do you go about it? Multiple products. Okay, this one doesn't differ significantly from the first one, although it does. Because now this one, the first step is, having done the others, you're supposed to determine the throughput. Determine the throughput per unit for each product. Because the products will be many. Like in this question of ours, the previous one that we're trying to use has 2 products, and I will use that one. So you determine the throughput per unit for each product. And the next thing you do is that very answer that you have, the throughput per unit. You try to now get throughput. Throughput, actually, I want to say the part 1 per factory hour. That the answer you have in 1, you now try to get it as per factory hour. Shall see how we do about that. Then, after doing that, you now rank. Okay. Now, in ranking, the largest becomes first. Okay, in that order. Okay, second largest, second, third largest. Okay. Then after ranking, we do what we call allocation. We allocate the limiting factor. We allocate the limiting factor to the best. Okay. I'll explain more as I do this. English will not come out well. So you allocate the maximum or the limiting factor, allocation of the limiting factor, or the bottleneck. Okay, as we shall see. Now, after allocating, then by allocation, by the way, you determine now, you obtain the output mix. Okay, we're going to see how we do that. Let me see what someone's saying. Now, how do you know that it will be the smallest output? I don't know what you say. If it is a single product, it is easy, yeah. That depending on okay, just guys, I'm thinking back. Just how do you know that the output is smallest or is small? I gave you a scenario here that labor, the maximum hours that you have for labor are 20. That's what you have on table. They're saying that on a good day, you're going to use 20 hours. Okay, that's what you have per day for labor. For machine, you have 15. Okay, but again, the same information will tell you that for a single hour of labor, what you can produce is 4 kgs. And then for a single hour of machine, what you can produce is still 4 kgs. So what does that mean? It means that for labor, if you use the maximum that you have, the 20 full capacity, you're going to produce 40 kgs. However, if you use for machine hours, the full capacity is 15. If you try to maximize the entire 15, the best you can produce is 40, is 60 kgs. So as you can see, that because machine hours give us the least, then our limiting factor will be machine hours. I can change this just to see how to go. In case one machine hour maybe gives us less. Maybe for machine hours, one gives us probably, say 8. Yeah, for a single machine hour, you actually produce 8 kgs. How will things turn out? Now, it means that for a maximum of labor hours, they will still remain at 80. But for this one, the maximum is actually produce over 120 kgs. So now our limiting factor changes. It ceases to be machine, but rather labor hours. Okay, depending on the output, is how we base on the limiting factor. Whichever, given its limitations, that the maximum is maybe 20 and 15 respectively, the one that gives you majority output or the highest output is not the limiting factor. Okay, the limiting factor is the one that gives you the least output. I hope I've answered you on that question. So let's get back to this one. Okay, so these are the steps you're going to follow, and we're going to apply them on the question that I already shared. I can share it again so to move about it chap. Okay, so you're given these two products. Okay, our first step, you're going to find the throughput for each product, and then accordingly, you're going to determine the throughput per factory hour. Then we rank, then we allocate. So this is the information I have. Let me go to the Excel and apply it. I think you guys already have this question. Okay, if you don't have it, we shall be going forth and two so that we're together. Okay, so now for questions that have multiple products, always the schedules don't change. You have details here. The schedules make you a bit organized. Let me put alongside the workings that I put so that you don't. You have A and B. You have products, then you have details. Okay. So what's for sure is that we want to determine the throughput per unit, and you can't get that unless you have a selling price per unit and direct material costs. Direct material costs per unit. Okay, these are costs. So these were given in the question, and for A, its price is 7,300. For B, we already saw it. It is 24,800. Okay. Then material, you have. Am I giving the right answers? I think it's a material cost, not the selling price. Sorry, these are material costs. Okay. I think you have 70,000. Then here we have 64. Okay. Okay, guys, throughput, you're only interested in material costs. Don't be confused with variable costs and any other thing you see. You're interested in the selling price and the material costs, mainly, and then the fixed costs, what you call the factory costs or the overheads. Okay, so then here you determine your throughput. I hope you're seeing my spreadsheet. The throughput, we already talked about it. You get the selling price minus the cost. So as you can see, throughput these are big figures. Okay, but that's not your problem. You are not here to analyze why they're getting a lot of profits or what. Okay, your issue is it unit cost? Yes, unit cost. How much was it? 7.3. Did you have a selling price? Yes. All right. So what is your throughput per unit? Per unit is very important to the extent that in case these values are given as sales and revenues, I mean totals, you must get the total and divide it by the number of units. Okay. I'm saying in case, yes, yeah. In case you are given, okay, sales or revenues. Okay, total revenues. For A, you're given, this is B. Okay. So you're given maybe 20,000. I'm just giving a scenario, so don't overthink about it. 10,000. Okay, so these are my totals. Then you're given total direct material. So maybe 100,000. And this was 150. Okay, so what you're going to get is total throughput. So throughput. Okay, so you're going to subtract sales minus total materials. Okay. So how do I get therefore throughput per unit? What you do is you bring here the number of units sold or level of production. So assuming maybe you have 10,000. And here you have maybe 15,000. Let me use 12. Okay, you divide and get throughput by what? Per unit. Very important. Okay, which is given by total throughput divided by the number of units produced. Okay, so this will be our throughput per unit now. That's what you'll bring here. Okay, so we continue. Now, first step is determine throughput per unit. The next step is to determine throughput per unit per factory hour. That these values here, this throughput that you have here per unit, you're going to get it as per factory hour. So how do we go about that? You bring here just a moment. Okay, how do you deal with it? You bring here the bottleneck or the factory hours. You must bring them. Okay, and looking at this per unit. Okay, you can divide this. They must be in the same magnitude. Eh? If the throughput per unit, then factory hours must be per unit. Okay, so these were still given in the question. If we go there and check it out. Here, but they say that if I already say that where is maximum capacity or limiting or limited to, that means that it is the bottleneck. Okay, so they said if the maximum capacity of 11,000 hours, which has been identified as the bottleneck, even specific, that limits the overall production or sales of products A and B, the bottleneck hours required per product unit for A and B, okay, it is per product unit, okay, for A and B is 0.8 and 0.7 respectively. So meaning that here you have 0.8, here you have 0.7. I will just share the screen now. Okay, if I share the worksheet again. Okay, I hope you can see it. So this is what was said. The limiting factor per unit was this. Okay, now I'm good to go. Then I continue. Okay, I'm still on step 2, which says that you're supposed to find the throughput per factory hour. Factory hour. So this I will use it as throughput per unit divided by throughput, I mean factory hour per unit. That's what you will get. Okay, I hope we're together. This one already talked about it. Throughput per factory hour. Per factory hour is given by either total throughput divided by total factory hour, or throughput per unit divided by factory hour per unit. So I'm using the later, which is this. Someone should mute. There's someone who's not muted. Okay, please mute. So that is it. That is step 2. Now step 3 is you rank. Okay. Now in ranking, like I already said, that the largest comes first. So these are 2, so the larger basically. So in ranking, we're saying that which one is big? A is big. So you say this is first. This will be second or last. Okay. So after ranking, now you allocate. Step 4, allocation. In allocation, we shall bring products first. Okay. You bring them in the order of ranking. So your A will come first. Okay. A is not coming first because it was first in the table. It's coming first because I ranked it as first. Then B. Okay. Then the other thing you look at is your output, expected output. Okay. If you go to the required part, okay. The required says that what you're looking out is the maximum demand that A and B have accordingly. Okay, the maximum demand. What are they saying that the market can afford to buy? Okay. So here what you have is they're saying that production and sales of product A and B are 12,000 units for A, and B is 4,500. So these are the maximum that the demand is out there. That for A, if you produce 12,000, they'll buy them all. Produce 4,500, they'll buy them all. That's your estimate. Okay, so if you go to I hope you have seen that. Okay, so if you go to our table allocation, what we do is we shall say, okay, you're saying that for A you need 12,000, and for B you need 4,500. Okay, this is our demand. Okay, so at the end of the day, we want to maximize both. If we didn't have any limiting factor, if raw materials were there as we really want them, then we don't have even to check which one is best, which one is what. We just produce them all. Okay, but the challenge is because we have a limiting factor that you can't produce the complete A and complete B. You have to now prioritize. Okay, and trying to prioritize, pardon, from throughput per factory hour. How do you know? Okay, just a moment. Throughput per factory hour. We're saying that this is the formula. Let me take you there. Here, return per factory hour is the same as throughput per factory hour. That's 2 formulas. You have throughput per unit divided by factory hour per unit. And this one here. So I'm using this. For multi-product, you always use this one. Throughput per unit divided by factory hour per unit. So I'll come and find my throughput per unit, which is this. I computed it. Okay. Then factory hour per unit was given in the question. Okay, they say that factory hour per unit for A was 0.8 and for B 0.7. So therefore, throughput per factory hour or return per factory hour is the same as throughput divided by factory hour. You'll have this. Okay, Christine, I hope I've answered you. So back to allocation. So these are your full demand. In case you didn't have any limitation, you just produce this and go away. Okay, but the challenge is that you have a limitation. Now, how we use that is you get this and ask yourself, what's the rate, okay, of consumption? In this case, I mean, what's the hour per unit? Okay, what's the factory hour per unit? They are given, they are here. You have 0.8 factory hour. Then here you have 0.7. Okay, that is what you have. Now, how much therefore for A, because A goes faster, you ask yourself now how much hours needed. Hours needed, maximize A. For A, you want to produce as much as possible. So that's why you actually begin with it. So if you consider the 12,000 that is demanded, do you have enough hours? Let's see. This times that, we have 9,600. This is a good number. Okay, because our limiting factor is 11,000 hours. Okay, this was the maximum capacity from the question. I'll take it back to show it to you. Maximum capacity. You only have 11,000 hours. Let me show you that. Here, they say that if the maximum capacity, okay, of 11,000 hours, which has been identified as the bottleneck that limits the overall production, A and B. Okay, so they have just told you that this is the maximum you have. So back to the question. Okay, so 11,000 hours, but if I produce A alone, I can use 9,600. So 11,000 is still have some. Okay, but now the challenge is on B, which is the second option. That you want to maximize A because it has the greatest throughput. So you want to produce as much as possible of A. That's why you end up producing all of them. But now for B, 4,500 requires, if you may just consider it, if it's produced 4,500, you will need 3,150. When you add these together, they exceed the capacity of 11,000. They exceed the capacity of 11,000. So that means that we can't produce the entire 4,500 therefore. So in this step, we normally work backwards. You will say that how many hours are left? Okay, what is left is 11 minus 9,600. Okay. Now, then you ask yourself, how much do you need for a single unit? You need 0.7. This one is constant, doesn't change. However, so meaning that what I can produce can't be 4,000 anymore, but rather this divided by that. Okay, 2,000. If this is disturbing, you can always put an X there. You say X. Okay, so you say 0.7 times X. Okay, should give me 11,400. When you make X the subject, you will see that clearly that X is equal to 1,400 divided by 0.7. That's how I end up having this as this divided by that. Okay, so our optimal mix therefore that we can afford with these 11,000 hours is only these 12,000 units of A and 2,000 units of B. That is your mix, optimal mix that you can maximize. Okay, so let's continue with the question. So they asked for you to compute the mix units of product A and B, which you have done, which will maximize the net profit. Okay, and the value of net profit. The value of net profit, let me take you there. Before I continue with my throughput, unfortunately, there are 10 minutes left on this link, so I don't know, but I can still just step by step, still fine. So how do I get the net profit? Net profit, whenever you're dealing with throughput, as far as throughput is concerned, it's given by throughput itself, throughput minus all other costs, all other costs, of course, with the exception of what? Of the material costs, because they're already deducted. So that's why I'm saying all other costs. So therefore, if we are to apply it here, what we have here is number of hours and number of units. So you can apply the throughput. So you put here throughput per unit, which we already computed. Throughput per unit for A is this. For B, it is this one. Okay, per unit. Therefore, my total throughput. Okay, total throughput will be given by throughput per unit times the number of units that are produced. So for A, it is only 12,000. For B, I'm still saying throughput per unit times the number of units of B that I produced, which were 2,000. Okay. So my total throughput so far, when you add the two, is given by this plus that. Okay, now from this total throughput, like I said, you deduct all other costs. We had variable costs, remember, and variable costs. I'll just show you those in a few. Then you had fixed costs. I think the working is on variable costs, which you have to compute, but for fixed costs, it was given as 140,750. Shall check. Okay, so back to the question. Okay, here. So we're saying that total fixed costs were given as 147,50. Okay, 140,000. I mean 140,750,000. But I had a variable cost here. They said variable overhead costs are 162 for A, then 9,600 for B. So let me put them somewhere. Where should I put them? I can put them here. Okay. A, B. This is 16162. Then for B, it was 9,600. Okay, these are variable costs, just to emphasize variable. So variable costs depend on units here. So you bring here your units. You're saying for A, it is 12,000. For B, it is 2,000. So my total variable costs saying is variable cost per unit times the number of units produced. That's what you have. Then you add them together. So my total variable cost, therefore, is this plus that for A and B. Okay. So therefore, my net profit is going to be given by total throughput, which is 770,800,000 minus variable cost minus fixed cost. So it's going to give me 416,000. That is my screen. What's wrong with it? I'm not sure. Oh, wow. Sorry. Sorry. I'll share it again. So we're saying total. I hope you saw the part of total throughput. Okay. So for variable cost, we are saying we're given it for A and B per unit. The variable cost per unit were these 16,162, then 9,600 for B. So to get total variable costs, you multiply them by the respective units. So for A, it's 12,000. For B, it is 2,000. The number of units produced, giving me these totals for variable costs. Okay, so to bring them into the formula, this one here, net profit is equal to throughput minus all other costs. I'll add them for A and B. I add them together, and I'll bring the total here. Fixed costs were given. Yeah. Therefore, net profit is given by total throughput minus total variable cost minus total fixed cost, and end up with that. All right. I've shared the Excel sheet. I hope you guys are seeing it. Yeah. Okay. So guys, that is how we do the net profit. Okay. Let me now complete with now the throughput. Okay. Okay. How do I do the throughput? Now for the throughput, now we come back to normal. Okay. How do we get throughput? Throughput accounting ratio. The formulas remain the same. It's given by total throughput. Total throughput divided by total costs. Total factory costs. Okay. Now this form here only works for multi-products. Okay. Otherwise, for single product, we use throughput per factory, or what you call return per factory hour. Okay. However, for multi-products, you get the total throughput for all the products and divide by the total factory cost for. Okay. So my total throughput, we already computed it here. Okay. It was given as this, unless they wanted for only B or C. Okay, but if they want for both, just get this, the total throughput and divide by total factory cost. Total factory cost, by the way, it's not just the 140. No, it's actually the 140 plus the variable cost. Okay, so you'll have it as this divide by that.